Hello, everyone. Thank you for joining us for the next in our Graph Guru series from TigerGraph. We know your schedule is very busy and your time is precious to you, so thanks for spending this 30 to 45 minutes with us. This is Graph Guru's number 22, Guarding Against Cybersecurity Threats with a Native Parallel Graph Database. My name is Victor Lee. I'm the head of product strategy at TigerGraph, and joining me today is Xinyu Chang, our Director of Customer Solutions. So we will be giving a talk again on cybersecurity. And we are using the Zoom video conferencing. If you're not familiar with it, we'll give you a little quick overview. There should be on your control panel a Q&A button. So if you have any questions that you want to ask the presenters, we'll have a Q&A session at the end. So please enter your questions there. If you're having some technical issue with Zoom, enter it in the chat or something else where you need a quicker response. You can use that, okay? And this is being recorded, and we will send you a link to the recording later today. And as well as we will have some of the examples that Xinyu will be presenting will also be available for you to download. So everybody is affected by cyber security issues and cyber attacks. Here are just a couple of the big incidents that have occurred in recent years. 3 billion accounts at Yahoo were compromised in the 2013 to 2014 timeframe. The Marriott International hotel chain with 500 million customers in the 2014 to 2018, a rather extended period in which they had vulnerability. eBay, 145 million users, and one of the credit screening agencies in the US, Equifax, reported the personal identifying information, such as social security numbers, birth dates, and home addresses of 209 million individuals were compromised. And what's key there is you don't even have to be an Equifax customer per se, because different businesses share your information and gather it, and agencies like Equifax make it available. So more recently, I just searched this morning for ransomware attacks, and I came up with 3 or 4 different ones in the US and an international one. So here's some overall statistics gathered by CSO Online, which is a journal that focuses just on cybersecurity issues. They're from the same publishers that do InfoWorld and Computer World. 92% of malware is delivered by email. So email is a huge vulnerability. 56% of IT decision makers say targeted phishing attacks are their top security threat. So phishing, of course, where uses humans as the target if they try to fool you. So the human factor is a big factor. Ransomware is becoming a common concern for all sorts of organizations. There's ransomware protection, there's ransomware insurance even. So it typically can cost millions of dollars, and it can take months to restore, or you may have permanent losses. Some who are unwilling to pay the ransom have permanent losses of data. Other organizations have, through different types of attacks, have permanent losses. So the problem is huge. It attacks consumers as individuals. It attacks all sorts of different industries. It touches everyone. Now, what does this have to do with graphs? There's several ways that, since of course cyber attacks, as we said, affect everyone, it would of course have some relationship to graphs, but we think there's a special connection. First of all, the internet itself is a graph, right? It's a connected data structure. So all of these cyber attacks are using our electronic multi-network system of interconnections, whether it is the cellular network, email, the traditional internet, and intranet, all of these different ways of communicating data electronically. This is the medium through which these attacks are being made, and those structures form a graph. Then typically the attack patterns are a chain of events. So there's some sequence of things. So once you analyze a particular case, it becomes a path within the graph of data and the graph of processes. So a process could be, you could think of it as an object, you could think of it as a connection between objects. However you choose to model it, again, it's very graphy. And lastly, in many cases, you have a few perpetrators who then issue a vast number of attacks. So then you have a hub within your graph, and then it becomes not just the breadth, the depth of the chain of events. In this case, it is how many different connections are coming out of one hub, such as in a DDoS attack. And in that case, so we're hitting on both aspects of graphs, both depth of analysis and breadth of analysis. So since the attacks are, as we said, intimately related to graphs, then it makes sense to think about how you can leverage graph technology, graph analytics, as a defense. So as we said, first of all, your system itself, the data is a network. So the data exists, but you can also model your personal assets, your organization's employees, the different operational processes you have. You can represent that as your own graph. And once you see it, then you can think about where should you be monitoring? Where are there vulnerabilities? And there are some well-established patterns for cyber attacks. And some of these patterns, you can again express within the graph and build up your defenses that way. If an attack actually does occur, then the graph assists you in both tracing to find the source upstream and then looking downstream to see what are the effects so you can take immediate action. And lastly, if your organization has historical data, and if you can merge that with other organizations perhaps in some sort of common anonymized data set, as you think of I think of the consumer software like from Symantec or McAfee or Computer Associates, all these other companies, they aggregate information from millions of users to find out what is the pattern. And they're using graph-like analytics. And you can do that too. So you collect the data and you feed it into machine learning and develop AI models to detect future attacks. So it's a big problem. It can be modeled with graphs, and you can take preventative and defensive and remediative action using graph. So I'm going to hand it over now to Xinyu, who's going to talk more into the technical details of some particular types and show an example of how you could use a native parallel graph like TigerGraph as part of your prevention suite.
Okay, hi everyone. So I'll start with the motivation of why do we need a native parallel graph to resolve the cybersecurity problems. The first reason is the data size is pretty huge. Like one of our customer, their data log is sized like around 1 terabyte today, and they stored it in like a Splunk, and it's almost impossible to extract the insight from that. It takes very long time for each query. And the second reason is usually to answer a cybersecurity question, we need to integrate like multiple data sources, including the log files, the infrastructure information, and the user information. We'll come to details of that later. And the third reason is the data is interconnected in the multi-level data structure. For example, for service, a service can have microservice, and a microservice may call another microservice, which make it like a multi-level structure. And so is the domain subdomain structure or organization chart, if you also want to include that to your cybersecurity solution. And the fourth reason is it is required to do deep link analytic to answer those cybersecurity questions in case we want to do anomaly behavior pattern matching or any like source tracing problem. And the fifth reason is we need real-time response to minimize the loss, which with a native parallel graph, you are able to like get all the insights from the database in like a real-time manner. And coming to integrating multiple data sources, so there are various data sources that we can put to your cybersecurity solution. For example, of the service info, like what microservice will be called by your service, like a server info, where is your servers, where are your servers deployed? Is there any VM running on it? Who is the administrator of that server? And so is the user info, the permission of the user, the organization chart of the users, and as well as the domain URL and the IP information, and the resource information, for example, the database and the files and the permission required to access those database or data files, and which is the takes the march and the last, the system logs, which takes most of your storage, which has a very large data sets to to store them. And this is the graph view once you integrated all the data sources. For example, so this is a service. A service can have an alert of any kind, and the service can have a microservices. And the microservice may just query from a database or output the result to a file. A file may have a URL, and each service can have a IP address, and the IP address can belong to a certain domain. And the services can be deployed in the physical servers. And the physical server can have its status, such as CPU storage and memory usage. And the user here can serve as administrator of a service or a server, and the user can also submit the request to the services. And a user can report to another user, and the user can also have a list of attributes such as email or device, and the device can be associated to an IP address. And also a user can work for a department. So the list can go on and on. We can integrate a lot of things to construct a graph in the cybersecurity solution. And within this graph, we can ask a lot of questions. So this is the whole list of attack pattern that we got it from CAPIC, which is the online community for the common attack patterns. So we won't go to the details of each attack pattern, but the point we are trying to make here is like the attack may like abuse existing functionalities, make some spoofing or fake some information, try to change the resources to result other applications to crash or become misfunctional, or like manipulate the system resources. It does flooding or print like scan all the APIs to find any errors and just result in the chaos in the system. There are many ways to cause trouble in the system. So to use a graph, we have there are like 4 graph use cases in the cybersecurity domain. The first one is we can do run pattern matching to detect any malicious user behaviors. And we can also trace the source of an error alert or any type of problem. And also we can do anomalous detection within the graph. And the last one is that we can extract those graph features to help your machine learning model to provide more accurate results. Okay, let's use some examples here. So these are there are two examples for pattern matching. For the first one, it's like it detects a pattern in the graph if a user add a mobile disk to the server and then behave a file moving event. And then after that, he removes the mobile disk from the server. So this is a graph representation of that type of a pattern. Okay, so with the pattern matching functionality of the graph database, this type of behavior can be easily found in real-time manner because it's just like a pattern of vertices and the edges in the graph. And the second pattern is you want to try to detect if any file read event actually happened to the restricted files that without firewall checking event before that. Or similarly, has any user behaved something that is beyond his permission, but he isn't logged in, or he is like having the lower permission. We can detect all kinds of malicious patterns as long as you can have your query defined in the graph. And here are some examples of tracing the source of an error alert or problem. For example, if a file corrupted alert happens in the system, we want to trace down, okay, what service had this problem? And then further we see, okay, which file was read by this service before having the alert. And then we want to figure out which user performed this writing event, right? That is the last few users performed the file writing event, right? And then we want to find out, okay, which IP do those users log in from? So to trace this type of source, we may like in the graph, we may need to trace like a traverse like a 1, 2, 3, 4, 5, 6, 7, even 7 hops. So if we do this in the traditional like relational database, it's about like 6 joins. It takes a very long time to figure out the source. However, with graph database, we can obtain this insight in real-time manner. And another example is whenever we have alert say, okay, one server with extremely high CPU usage, which is quite abnormal, then we can trace down where do the requests come from, which service it comes from, and for this service, who log in to that service and performed and send out the request. Then we can figure out, okay, which user ID or IP actually send out all those requests, which also takes a lot of hops on the graph. And the next example is detecting anomalies. So for example, we can do flooding detection. That is, one server receives many more requests than usual, or footprinting detection. That is, maybe one account or one IP address scans over all kinds of APIs in order to find a vulnerability in the system. We can detect that as well with the graph database. And the last one is we can extract graph features to feed the machine learning model to have a better accuracy and a callback rate. For example, there is a new application to the system that it wants to open new account with all this list of IP address, email, and the devices. Then we can just do analytic on the graph to extract those graph features. For example, we can extract for the new application, what is the number of shortest passes to the blacklisted user and the IP addresses? What is the number of blacklisted user or IP in 1 hop, 2 hop, and the K hops? And what's the KNN? What's the K nearest neighbor that sharing the most common features. If most of the neighbors, they are just bad guys, then which means makes the new application more suspicious. And the last, we can also analyze the user behaviors. If one user's behavior is highly similar to those blacklisted guys, then we can also use this as a useful feature for your machine learning model. Okay, so all the features list can be used for your machine learning. And now I'm giving a demo here. So right now we are looking at the front end UI of TigerGraph, which is Graph Studio. So with Graph Studio, you can create an end-to-end solution, TigerGraph solution by just a drag and drop. And now here we are looking at the schema design page. In this page, we are looking at the vertices and the edge types defined in this graph solution. You can see that we have an event vertex lies in the middle. Event has its start date, end date, event type, and a return code or an endpoint. And we also have IP address of this event, the user that initiated this event, and the service initiated the event or who received the request of this event. And also the server processing this event and the device has been used, or the resource has been serving as input or output of this event. And both service and the server can have an alert, and the alert has a specific type. So these are the vertex and the edge vertex type and the edge types that will be used for this demo. Okay, once the graph model is defined, we can load the data into this model. So you can see these five icons are the input data source to populate the graph. So here is where we define the mapping relationship. For example, from this service.csv file, we can load all the info regarding this service. Like we define, we say we use the service ID column to populate the service ID, and use these two columns to populate the service attribute. That's how we ingest the input data source to the graph schema. And once this is defined, we can start the loading job from this page by clicking on this launch button. Right now, you can see we have loaded a small graph, and also we can explore it from here. But now I just picked 5 random vertices under each type. But double clicking on the server, we can see all the events that happen to this server. And by double clicking on the event, we can see all the details of this event, the start date, the end date, and the type. And you can see the type of the event is read from a resource. And this is the resource name. It's a MySQL server. And also by double clicking it, you can also check all the other events regarding this data resource. Okay, so this is pretty much how the graph looks like. Now I'm running a few queries. So there is a list, there are 5 queries that is written in GSQL for different cybersecurity graph use cases. The first one is the alert source tracking. Tracking is pretty much the one I showed in the slides. That is to starting from a file corrupted alert and trace all the way down to the IP address. Okay, and this is a batch query. It starts from all the data corrupted alert, and in the end, it will track down the IP addresses. So by clicking on the run query button, we have a result visualized here. You can see this is the alert type vertex, which is the data corrupted alert. And traverse one more hop, we can get all the alert happened in the history. And then find, okay, which service got this alert, which event, read the event the service had, and also the data resources that was being corrupted, and then figure out who are the writers, the output to the data resources, and then we find, okay, where do those guys log in from? We figure out the IP addresses of those guys. And you can see in the graph, it's like 1, 2, 3, 4, 5, 6, 7, 8 hops on the graph. And also we have a query that is check, is there any file reading event to the resource that is restricted, but there is no firewall event before the event, the reading event. Okay, so just run it. You can see these are the list of IP address that hide that malicious behavior pattern. And also you can see for this IP, there are two reading events happened in these two timestamps that without like a firewall checking. Also, we can do flooding detection. So this is a use case that there is a service received a large amount of requests from various different IDs. But assuming those IDs are compromised and logged in from maybe very similar IP addresses, let's run the query and figure that out. Okay. Okay, so now these are the list of services that was in the result. Like usually, in average, a server may receive like a 3.7 request. However, the result has 41, which is the standard deviation is 10. So we adopted a simple algorithm to detect the anomalous behavior. That is, the number minus the average is larger than 3 times of the standard deviation. Then we will identify the number to be an outlier. That's how we handle it. Okay, and here, these are the IP addresses that send extremely high number of requests to those services. And this is a service ID. And this is the average number. And this is the standard deviation. Okay, and also for footprinting detection. That is the question to ask here is there a user ID that send many different types of requests to a service within a short period of time? Let's run it. Okay, now we set the time window to about like 5 minutes in May 1st, 2019. Okay, a 5 minutes window to see if is there any like a user account send a whole bunch of different requests to scan the vulnerability of a service. After running it, we get 2 results come back, which is user 1. User 1 sent to service 13, like a totally 41 different type of request. But the average user only sent 4 type of request. And the standard deviation is 10, which makes user 1 an outlier in this case. And also, the last example is like how we extract the graph feature given the new entity. For example, there was a new IP address visited the system or a new application for the user account. Then we can just start from it. We collect the number of shortest paths to the blacklisted entities. And let's start with this IP. Yes. And we want to traverse as far as like 2 hops. 2 hops, nothing. Okay, 3 hops. Right, and we already got some result in the 4 hops. And this is the IP we got started, and then it checks within 4 hops what is the number of shortest paths to those blacklisted guys. And now we get number 18. And this number will just keep increasing when we try more number of hops. Oh, it's already pretty big when you go like up to 6 hops. So for 6 hops, we have number 725 shortest passes to those blacklisted account or IP addresses. Okay, and that is the demo.
Okay, thank you very much, Xinyu. So now we're going to open up the floor for questions and answers. If you have one, please enter it now. And we do have a few that people sent in beforehand. Actually, one regarding your demo. So when you talked about identifying outliers, you talked about a specific condition, I think 3 times some factor. how would I put in a different or more general or parameterized condition?
Okay, so in this demo, we adopt a very simple solution to detect the outliers. That is the number minus the average number larger than 3 times of standard deviation. So actually, you can change the number 3 to a parameter to like include more outlier or less of those. Yeah, and also since GSQL is a Turing complete language, you can also adopt a more complex technique to detect the outliers in that case.
Okay, great. Are there particular applications or industries that are using graph-based cybersecurity? Does TigerGraph have instances of where people are using this approach for their cybersecurity?
Yeah, the cybersecurity, actually, almost all industries has this cybersecurity problem. As long as they have a very complex internal system involving all kinds of service applications and IT infrastructures, right? Like we have customer having this problem from investment bank, credit card company to some like customers that they are especially in this like a cybersecurity field.
Mm-hmm.
Yeah, they would use graph to solve their problems.
Okay, and what if there are a number of other products out there who are trying to address the cybersecurity problem, some aspect of it? Is TigerGraph able to integrate with some of these other tools?
Yes, we can actually integrate with a lot of different tools using our RESTful API and data loaders. Yeah, like one of the customer, they would dump their log files stored in Splunk, and then after some conversion, we can just ingest all the log files to TigerGraph.
Great. Want to thank everyone for attending. If you do have other questions later on, so this will be available. The recorded video will send to you, and you can contact us later if you have any follow-up questions. You can try TigerGraph for yourself. We have TigerGraph Cloud with a free version. You can try our test drive online where we have online demos. The cloud has over a dozen different starter kits, some of which address anti-fraud and related cases. We have the online demos. You can download the product. As I said, this Graph Guru's presentation, the demo that Xinyu showed, and the scripts that go with our previous Graph Gurus are available on GitHub. And again, you can send us a question. If you have a more technical question, we invite you to go to our developer forum on Google Groups. And lastly, these are general Graph Gurus that we present to anyone who wants to sign on the web, but we are also presenting a series of in-person presentations where you can have a much more intimate conversation with our team of experts. So we have ones coming up in Boston on November 20th and in the San Diego area on November 21st. So if you are near one of those, we invite you to come to our website and sign up. If you would like to have a Graph Gurus presented in your area, we would love to hear from you. You can send us requests at that link below at info.tigergraph.com/graphgurus request. If you can't remember all that, remember these slides will be available. So we want to thank you again for spending your time with us today. It's been my pleasure. I'm Victor Lee, and want to thank Xinyu for his time. And we will see you next time. Thank you.
Okay, thank you.